Hi, I'm Pictus and I'm a first year industrial engineering student at Bilkent University, and this is my lab proposal for my Physics 101 class. I'm going to explain you my experiment, which is called the investigation of conservation of energy in rolling motion, a comparison between a solid cylinder and the hollow ring. So the aim in my experiment was to investigate how mechanical energy is conserved during the rolling motion of rigid bodies, and to evaluate how the moment of inertia affects the distribution of energy between translational and rotational components. By examining two objects, a solid cylinder and a hollow ring, we aim to understand how differences in mass distribution influence their accelerations, final velocities, and energy transformations as they roll down an inclined plane. My experiment has several objectives. The first one is to verify the conservation of mechanical energy by comparing the initial gravitational potential and energy of each object with the measured total kinetic energy at the bottom of the incline. The second one is to measure and evaluate the final linear velocities of both the solid cylinder and the hollow ring and compare these values with theoretical predictions. The third one is to analyze the effect of moment of inertia on the acceleration and the final speed of rolling objects. The fourth one is to calculate the fraction of kinetic energy stored as rotational kinetic energy for each object. And the last one is to assess sources of experimental error, such as friction, air resistance, misalignment, or measurement uncertainty. In this experiment, as materials, we will use an inclined plane, one solid cylinder, one hollow ring with similar radius and mass to the cylinder, and one digital balance for determining their masses, and a ruler for radius measurements. The results of this experiment demonstrate clear differences between the rolling motion of a solid cylinder and a hollow ring, confirming the theoretical role of moment of inertia in determining their speeds. Across all trials, the solid cylinder reached higher final velocities than the ring, which aligns with the prediction that objects with lower moments of inertia convert more gravitational potential energy into translational kinetic energy. The hollow ring, having more mass distributed away from its center, required more rotational energy and therefore accelerated more slowly. Although the theoretical and experimental values show some discrepancies, particularly for the hollow ring, the trends remained consistent. The larger percent differences for the ring likely resulted from greater sensitivity to friction, small slips, or surface imperfections, all of which affect objects with higher moments of inertia more noticeably. Meanwhile, the cylinder's smaller discrepancies suggest that its motion more closely approximated ideal rolling without slipping. Overall, the experiment supports the principle of energy conservation and reinforces how mass distribution influences the balance between translational and rotational energy. The findings confirm that the solid cylinder rolls faster and loses less energy to external factors, while the hollow ring devotes more of its energy to rotation, resulting in slower motion. Despite minor measurement uncertainties, the data aligns well with theoretical expectations and provides a clear demonstration of rolling dynamics.